thank you. Thanks, everyone. Really excited to be here. I'm Daniel Hewlett. I'm a principal AI engineer at LinkedIn, and I was the AI tech lead for this hiring assistant project. And I'm going to turn it over to Karthik here to introduce things, get us started, and I'll be back in a minute.
Hey folks, I'm Karthik. I am a distinguished engineer at LinkedIn, and I'm responsible for all the generative AI applications and the generative AI platform at LinkedIn. So I'm going to start off this talk talking about how we started. So in 2022, 2023, ChatGPT was the rage. All our execs were like, we need to do something with GPT. It's super cool, and we did not know what to do. So we said, hey, you know what? Let's start with a really simple product. We built this product called as collaborative articles, which is very simple in the sense that we ask GPT to pick a topic, generate an initial article, send out notification to experts on that topic, and ask them to collaborate. Again, use GPT to enhance the article. So effectively, the article was collaboratively iterated and improved on. Now, the reason we picked this use case was very specific. Firstly, we wanted the simplest integration possible. It's essentially prompt in, string out, nothing fancy. We had hardly any retrieval augmented generation, simple retrieval augmented generation. Most importantly, we did not have any user input, right? Everything into the prompt, there was zero user input. It was all essentially the system generating itself. We obviously had no kind of memory, simple system. Everything was done offline, so we did not have to worry about latency, capacity, all these nasty problems. And we used GPT 3.5 to start with and GPT 4. Simple product, we learned a lot from it. And since then, it's been sunset. Then we come to what is called as the coach era, where we built a bunch of conversational assistants. Here we decided to up the ante a little bit. We started having chains of prompts. Typically, we would have an intent classification / routing prompt, followed by a planning prompt to pick the right set of tools to execute, followed by the actual synthesis prompt. We started using retrieval augmented generation pretty heavily here, connecting to a bunch of internal systems. We obviously had user-defined input. As you can see, people are asking questions. It's giving responses, which essentially meant we had to ramp up our trust defenses quite a bit to guard against malicious input. We needed conversational memory here because people could ask questions about stuff they had already asked. We had to do online inference because it's an online product, so latency and capacity were important to conserve. And here we used a combination of OpenAI as well as in-house models. Right now, since the last year, we are in what we call as the agent era, where instead of having just conversational assistant, we've moved to more of task automation using agents. Instead of prompt chains, we have prompt graphs now. So these are graphs of prompts which get executed, right? We have pretty advanced retrieval augmented generation, which we will cover in some of the later slides. We have these abstractions for skills, which is slightly more advanced than tools, again, which we'll cover later. We have an explicit concept of human in the loop, where if the agent cannot do something, it escalates to a human, and after that, the human responds, so the human is actively in the loop. We have conversational memory, which we had before, but we also have this cool thing called as experiential memory, where the agent learns from its experience of interaction with the human, and it stores things. And of course, right now we have online, offline, and nearline inference, and again, we'll cover why. And we are using a combination of different models right now. And without further ado, I will hand it over to Danielle to talk a bit more about the hiring assistant product.
Thanks, Karthik. So this is a product which is very new and we're very excited about. This is our CEO of LinkedIn announcing the hiring assistant just back in October at our Talent Connect conference, which is an event we hold for recruiting leaders and people in the HR space every year. So that's where we debuted this. It's currently in a limited charter with a select group of our partners, enterprise customers. I'll say more about that in a minute. I want to take you on the journey a bit for how we developed this new hiring assistant and what it actually does and looks like, and some of the things we learned along the way. But to do that, I'm going to go back a little bit so you have some context on the problem that we're trying to solve here. Because it may not be something that you have used yourself. So let's just get a little engagement here. Last talk of the day. So how many folks have ever received an in-mail from a recruiter on LinkedIn? Let's see. Okay, everybody. How many people have used Recruiter Search to find someone and send them an in-mail? Okay, we got a few people, which is awesome. But most of you have not, right? Most of the folks that are using LinkedIn as LinkedIn members are on the receiving end of these in-mails, and it's one of the ways that you can find new jobs and new opportunities through our platform. But today we're going to talk about the LinkedIn Recruiter tool and the new the generations of AI assistants and the new agent that we built on top of it. So I just want you to understand a little bit from the recruiter perspective what this has looked like. So LinkedIn Recruiter has been around in some form since 2008. So it was already around for 10 years when I joined the company in 2018. I've been working on it since then. So for a long time, this had many new features, many iterations, but there was a basic way that you worked with it. So on the left side, you can see a set of search filters. There's, as of today, there's over 40 search filters and facets you can put on there. You can also create your own custom ones, as it shows there. You can do text searches. You can find people that are open to work. You can search about connections in your network, things like that. It's a real rich tool that professional recruiters use every day to do their jobs. And the classic sort of workflow we've had most of this time is kind of illustrated in the schematic there. So you as the recruiter, you would sit down and start constructing a search query. You would think about, who's the kind of person I'm trying to find? What kind of skills would they have? What kind of titles would be good for the position I'm trying to source for? You'd build a structured query like on the left there, using all those facets and tools. You'd get back some results in the main search area. It's not shown here, but it's a list of LinkedIn members. And then our AI would be behind the scenes finding those candidates and putting them, prioritizing them for you. But you would review them, and then based on that, you would refine your search query. Maybe there's just too many, you want to add some more filters. Maybe they're not the right kinds, and so you have to think about what to do there. So it's a very human-driven process. Now, as Karthik mentioned, last year we kind of took a step forward to our AI-assisted version of Recruiter Search. So we rolled out AI-assisted search in our release we called Recruiter 2024 in the first half of last year. That became available to all the users on the Recruiter product. And what we did here, this is kind of in that coach Copilot space, right? We added to that workflow from before, so I brought the same flow back. But what's different is we added AI in new places in the flow. So wherever you would go in, previously you had to do something, you could only do it manually. You could now use natural language to talk to an AI assistant and have it do that for you, and I'll show you some examples in a minute. So most notably, perhaps you could, instead of having to interact with all those facets and widgets and navigate through all different things yourself, you could just say, hey, I'm looking for an accountant in New Orleans, right? And it will start and populate that. So it makes the UI more accessible to a broader group of people, but still fundamentally, once you do that, you have to check the output, make sure that the query is what you want. You have to, review the candidates yourself and so on. So there are some opportunities. We learned a lot from this, and they really informed our agent design. So one of them is, when you're thinking about building agents, right, we want to prioritize the most time-consuming cognitive tasks, right? And for recruiters, that task is reviewing the candidates and going through, potentially hundreds of candidates that they're looking at profiles, looking at resumes, trying to figure out what it is that may make this candidate, meet the qualifications that are required for the role or not, right? And trying to identify those candidates to shortlist and prioritize. So that's something that takes a lot of time for recruiters, and we've always been helping in a way with our retrieval and ranking system. That's a search stack. It's got ranking models in it and so on. But it's kind of behind the scenes. We're not working directly with that. And we didn't solve that with our 2024 AI-assisted search workflow. Another opportunity is that because we were taking natural language and translating it into the format of the tool that we already had, right? This is an example of taking, the space of natural language, which is very open-ended. Natural language semantics, you can say, an extremely wide range of things, and then we're trying to put that into a constrained kind of logical structure, right? And if you've worked on that kind of problem before, you know that there's a lot of information lost when you do that, right? And so there are things that you're just not going to be able to render properly into a structured format. So that was another lesson we took in there. And you're going to see how we address that in Agent in a minute. I'm talking just a little bit more about how we were building Recruiter 2024 and how that informed our agent design, which you'll see in a minute. So this is an example of that natural language search I was talking about. Here I've said, find me accountants in New York with experience in bank reconciliation, and it's done the job of translating that into those structured facets. Everything is standardized based on taxonomies of the entities that exist in the job space. And you can now edit that structured query just the same as you could before this assistant came out. But we developed this originally, the way you would when you're prototyping. You would take that text, you'd feed it into an LLM block, so meaning you have a prompt template, you have an LLM, you might have some RAG in there to retrieve examples for few-shot prompting, right? That's a single LLM block. But as you start to, once you go past the prototype phase, right, you really want to make sure that the quality of this system is top-notch. You want this to be something people who are using this tool as part of their jobs, right, professional recruiters, can use every day, and they don't have to think about, is the AI going to do the right thing or not, right? And if you have just this one block there, right, you are, even if you introduce things like, I'm going to use examples to try to show it how to behave to fix a particular quality issue, that introduction of that example could actually affect the behavior of something else in your system, right? This is the way LLMs work. They're non-deterministic, and the whole of the context that they operate over influences the output. And so to introduce some kind of, this leads to bottlenecks in scaling when you're trying to develop this system, and put a team of engineers behind this. So what we ended up doing here was going to a more modular architecture where we had a kind of manager or interpreter, coordinator, which would take your input and then figure out, okay, what kind of specialized areas, what sort of filters am I going to need to work with here? And I've kind of shown this schematically, right? This is a very simple way of showing it, but different sorts of specialists, which are themselves new LLM chains and blocks that someone could work on and improve in isolation. So for example, we could make sure that the location one really understands, all the nuances of locations. NY, it could be New York City, it could be the New York metropolitan area, it could be New York State. We can give it instructions around that without any of that influencing, titles or companies or any of those other things that don't have to do with that. So you can take each of these modules. This is a common paradigm in software development, right? But you can apply it to the construction of these GAI chains. However, I do want to mention one thing. There's a trade-off with this, which is that now, instead of one step, you have to go through 2 or more steps, and each of those steps can potentially have errors because LLMs are, after all, like statistical at the end of the day. So your errors can compound across these stages. So if you have 90% accuracy in both stages, you're going to have 90% of 90%, that's 81%, right? So you actually need to have the reason to do something like this is because you think you can engineer each of those subcomponents to a very high level of quality and thus have an overall better system by applying more either different techniques or more engineering effort across these different tracks. So that's some context from our coach era. And now I want to show how that showed up in building Hiring Assistant, and then how we address some of those opportunities that we showed there. So this is a brief video. Hopefully this will play. Okay. It may go by quickly, so I'll loop it back if it goes by too fast. But what you'll see here is a demo of our that we announced at Talent Connect. This shows the MVP version. Let's see if I can trigger it to loop.
You may want to press back and forward again.
Could you?
Yeah.
Oh, okay, back and forward again. Let's try that. Okay, nice. Yeah, so you can see what you're doing on the first step there is you're putting in your hiring intent. You could do things like attach a job posting, attach some notes you've made about the candidate you want to hire. Maybe you can even attach the resume of a candidate or an employee who's leaving and who you need to hire a replacement for, right? And instead of building a query for you, which means you need to understand the whole recruiter search UI and all of that, we're translating that intent that you put in there into a set of qualifications and other information about your role. And based on those textual qualifications, which you can read and understand as a person, right, and preserve a lot more of the meaning, right? We're not losing that meaning of what you wanted by having to go and turn it directly into that logical structure. We can apply LLMs at different stages here. We can also search for candidates using that intent, the natural language intent, and we can evaluate based on that natural language intent, whether there's evidence that candidates meet your qualifications, right? So all of that is enabled because we've changed the interface with the user so that we're no longer interfacing through the traditional search filters, we're interfacing through a natural language description of your hiring intent. And that's driving a lot of the new features here. So remember how we talked about kind of modular design in the design of our coach, right? Copilot kind of product, I should say. Recruiter 2024 AI-assisted search. Now here, in Hiring Assistant, informed by that, we take a similar strategy from the outset, but instead of building like particular LLM blocks, like I was saying, like a prompt with some other data around it, now the modular components are themselves sub-agents. I think if some of you were in one of the talks earlier today, they mentioned this type of design. But so what we're doing here is there is, similar to the previous example, the Copilot example, there is a kind of supervisor, but here it's an agent that can treat the other agents under it, the sub-agents, as tools that it can invoke and pass information to, and they can return information back to it, and it can act on that. And so everything we did before, that whole flow chart I was showing earlier, that's all under now one skill under one agent. So it's the same principle, but it's applying hierarchically. And this is also going to enable the same things where we can develop more effectively and evaluate things in parallel. I'll talk more about that. I'll show you an example of how this works in practice. So the user gives an input. It goes into our supervisor agent. The supervisor is going to determine what is that intent about? What is the user trying to do here? And then based on that, it's going to send the request, possibly with some other information, to another agent. It's going to send some information to the intake and say, hey, I've got an intake, a request for you intake. Here's the kind of information they gave. Here's some other context about the request. And then the intake agent will take over. It might use some skills to look up user preferences, maybe things that the recruiter typically does, or other things associated with this hiring project. And then based on that, it can generate a set of qualifications, which is what we were looking at in the video that I was looping a minute ago. And that cues off the rest of our flow. So I'll just show another example quickly. I'm just going to go through this one just to show you how a more complex flow, that's a basic one I just showed, but here we're going through and using our sourcing agent, which is going to read those same qualifications we just generated. And then it's going to use other skills, like the ones we talked about, to generate search queries. And then feed those through our recruiter search index, right? So we're leveraging everything we've built before, but now it's part of an agent, and this agent can run as many queries as it wants. It can run multiple different queries in parallel, explore the search space in different ways to better mimic what a recruiter actually does, right? They don't just run one search and say, here's the results. They're going to run that feedback loop that we were talking about earlier. So that's where we're going with this. Okay, so I want to next talk a bit about, I mentioned earlier that quality is really important. And one of the reasons to have a design that gives you a number of subcomponents is so that you can really isolate the quality of each of those subcomponents as you're building the agent. Because remember, we're building this whole thing up on top of what we already built, but all those sub-agents and that supervisor agent, all of that is new. We're building that up in parallel, last year to get this out in time for Talent Connect. So we approached, what you're seeing on the right is a schematic flow of the data through our system at a very sort of abstracted level. And you can see each of the different agents I described, and they're some of the GAI components or AI components that they use called out there in blue. And each of those has a kind of input and a kind of output format that we can evaluate. And now they may go through a lot of different internal steps to produce that output, right? But we can still evaluate them this way. So we went through a common quality playbook for all of these different agent components that we built in parallel. The basic game plan here is to make sure that we can iterate on the quality of each of them in parallel and independently, and build this thing from the bottom up. So starting with each of them, we would define rubrics for humans, use those as quickly as we can to transition to LLM-driven automated evaluation, because really the bottleneck in developing these tools, the unlock, is being able to iterate quickly to improve quality. And so the more we can move away from having to use a lot of human annotation, or having to use a lot of, for example, have a correct reference output for every possible example we're evaluating, moving to reference-free evaluation, right? Those kind of techniques enable us to move a lot faster and to iterate more quickly. And that's really how you can build this up. So we've got multiple dimensions of productivity. One is that we can develop each of these agents in parallel because they're modular, and we can also measure their quality in isolation. And then, of course, as we get later on, we're going to have to start stitching all of this together. Sorry, I went ahead too fast. To build up the overall agent there. Okay, so one thing, the last thing I want to talk about on the agent design is of course LLMs and how we proceeded there. So the basics of this, of our LLM choice, if I had to boil it down to a simple binary, would look kind of like this, right? When you're building up an MVP, a new product, you want to iterate, especially something like this with where we're changing the product interface, right? I mentioned we're moving from a traditional kind of structured search to more of a natural language-based search. You're going to be able to iterate quickly because you want to try out new product designs and also new prompting, new LLMs, new data as part of your chains and everything inside of these agents. So that means you want the best instruction following to be the most agile. And so you're going to want to go with something like the most state-of-the-art LLM. So during some of this development, it was GPT-4o, for example. But then one thing about this product is we also have areas that are high scale. So for example, if you think about that intake, that's one recruiter talking to one AI, right? It's a kind of scales with the number of recruiters. But if we think about evaluating candidates, which is what I'm going to talk about next, for a given job, you might have thousands of applicants, or for if you're sourcing, right, you might have a search, run a search, and come back with hundreds of results, right? So if we're going to evaluate all of those, that's going to scale with the number of candidates. And so that's a much bigger, orders of magnitude bigger scale. So there we want to use fine-tuned smaller LLMs. But there is a tension there, which is that, and this is showing how that candidate evaluation task works, but there's a tension when you use fine-tuned LLMs to develop something new, right? Which is that fine-tuning works best when you have a well-defined problem statement and you're just trying to optimize really aggressively to drive up quality within that problem statement. What if you're changing the problem statement along the way, right? That's why we wanted to look at general purpose instruction following models, right? So this is where, at LinkedIn, we've done some work that I want to share to develop a way to try to have both sides of that equation. But this is just, before I go on from this real quick, this is just showing you how it works. We're actually, for each candidate, taking the qualifications, the profile, and the profile and resume of the candidate, and then producing an evaluation that says, for each of the qualifications, whether the LLM was able to find evidence for that, and if so, it gives you citations that show you where those qualifications, where that supporting evidence comes from on the profile or the resume. So it has receipts. And so when building fine-tuned LLMs for this, we started with, we're not starting from scratch. So we've already, at this point, we had already built out applications on top of generally available, like general purpose LLMs. And they work reasonably well in jobs domain. And the reason is that a lot of job-related data is public. So for example, if you go through the Common Crawl corpus, which is used for training GPT and a bunch of other LLMs, you'll find over 4 million job descriptions that can be identified based on metadata associated with them. That's from this source here. So that means these LLMs are already quite well versed in things like qualifications and so on. But we also did some experimentation here, and as you might expect, domain-specific fine-tuning can still help. And here, the approach we tried for this at LinkedIn, in partnership with our core AI team at LinkedIn, is called multitask instruction tuning. So here, we're taking open source LLMs, and we're fine-tuning them on a set of LinkedIn economic graph data. So it's not actually this specific task, which is interesting. We're trying to train them to preserve their ability to follow instructions, but to understand the type of data LinkedIn has, so to get even better at understanding job postings, at understanding member profiles, posts on our feed, and so on. And there's a blog post there, which you can read more about that. I'll just show the flow chart quickly that shows sort of how this worked. So Eon here is the name that we gave to this language model. Our AI, core AI team gave to this. So this is showing you, I want to just show the second steps there. So for domain adaptation, we're taking, that's showing how we train it on a number of different tasks. And we're preserving the ability for it to follow instructions. So what that means is we end up with a system where, where it can outperform models of a similar size that are coming from open source, but you can still put in different instructions. You can iterate on your product as your product experience is evolving. So this is a pretty new area, but just want to share that because it's potentially a way for us to have a bit of both. And of course, the LLM that comes out can still be fine-tuned or distilled. And these are all things we're exploring very heavily right now, how to get even better performance for this task. So one of the things that made this possible, that we're going to hear about next, is our LinkedIn agent platform. So actually, all of these sub-agents are implemented on top of a common tech platform. And so Hiring Assistant itself is on top of that. And because of these shared foundations, just to show an example of how important this was, we were actually able to implement almost in parallel another version of the hiring assistant, which is built out of some of the same components, but is targeted at small and medium businesses who have a different set of needs. So for example, they may need more help with creating the job description itself or trying to figure out which types of candidates to reach out to, whereas professional recruiters might be more opinionated. So without further ado, I'm going to turn it back over to Karthik to talk about our LinkedIn agent platform.
Okay, thank you, Danielle. I hope any of you is not going to build another like recruiting agent. We don't want competition right now. But stuff we will talk about in the agent platform should be broadly applicable to all of you who are trying to build agents. So it all starts with prompts. Now you can think of prompts as really simple strings which you feed to the LLM, but it's actually way more complicated at scale. You typically have a prompt template with like placeholders inside which you fill in content which is specific to each prompt at runtime. You also want to have some guardrail instructions to prevent abuse for trust, responsible AI, etc. And you also want to ensure that when you have too many prompts, you want to have some organization like namespacing, use case-based segregation, versioning if you're trying to roll out a new version to try and see how it performs, etc. So rather than have the developers do all of this by hand, we encapsulated everything into a prompt source of truth service. It's just a simple facade service which essentially manages all of this for you. And here is an example of how it looks like. We have an app at the top level. You have like namespaces within the app. You have use cases under it, and you have different versions. And you have various ways to switch between versions, select prompts, load prompts, it gets registered. We have backward compatibility checks running. Bunch of things come for free so that the developers do not have to do this manually. The other important thing is every day a new model comes out and you want to quickly switch models. So you want to abstract out LLM inference as much as possible, right? So we have a choice of models. We use Azure OpenAI models. We also use on-prem hosted open source models, which are further fine-tuned. So what we saw is that the OpenAI chat completions API is pretty much a standard right now for LLM inference. So we spun up an abstraction which exposes this API. And after that, we have a configuration-based system via which you can go and you can change your LLM on the fly and call different LLMs. Now, the other thing this allows us to do is because we have a single choke point for LLM inference, we can do things like, okay, quota management. Hey, because LLMs are expensive, GPUs are limited, so you need to have quota enforcements. You can also do runtime moderation for trust and safety or like responsible AI purposes. So having this layer really helps us. So again, we put all this into an LLM inference service, which is just a proxy with some additional syntactic sugar, as you can see. The other thing is application framework. You do not want people writing prompts and calling LLM inference manually. I mean, you can, it's just not going to scale. Your code is going to look very clunky. So we had to pick a framework. So what did we pick? We picked LangChain and LangGraph for a variety of reasons, which I can get into offline. So I mean, it allows us to chain prompts, interact with memory, invoke skills, which we talk about in a bit, and do LLM inference. And what we basically did is we built some really nice adapters and helpers into LangChain and LangGraph so that our developers get all these out of the box and you do not have to do this manually. So anytime you pick a framework, pick any framework based on your choice, ensure you implement the right abstractions so that the developers don't end up doing it again and again. So here is a 100,000 feet view of control flow inside an agent. Typical control flow, right? You have a prompt, it goes through a planning phase, it generates a task, it gives it to a single task agent, and the result comes back. It's an iterative loop. It may need to be replanned, re-executed, etc., right? And ultimately, when you're done, you get the response back. So you actually have to do this at scale. You can't run this on a single machine, right? So how do you scale this? Classic distributed systems problem. Apply horizontal scaling to it, spin up lots of instances, and let all these instances process everything in parallel. But classic distributed problems return with a twist. The twist being that everything is very non-deterministic. So what are these problems? You have to have state consistency, which is very distributed, right? You have to handle traffic shifts. If you shift traffic out of a region, go to another region, etc. And LinkedIn, we do this a few times a day. You have to handle host outages. You're running something, the host goes down. Okay, you have to resume it on another host, right? You also have to handle ephemeral failures because, hey, stuff can fail all the time. Entropy is real. So how do you solve all these things? So we decided to use like messaging to solve all these things. So what we said is that, hey, all the communication between users and agents should be modeled as a message. So like, what do you think the message contains? Someone, anyone? Prompts. Okay, anyone else? Pardon me? Okay, so actually, if you look at the message, it's a combination of structured and unstructured data. The structured data is information which is already available as structured data. Let us say we have an entire job in a structured way as a JSON or something, we just like send it in. Why? Because, hey, if it's already structured, why go through the non-deterministic path of converting it into a natural language and potentially losing information when you convert it back into structured information? You may use it to interact with an API. It also contains a like non-structured component, which is free form like text, which is essentially instructions given to the agent asking it to do something with it. No, we don't send prompts. Sending prompts in messages is problematic, and we can talk why offline. So what this enables is distributed agent orchestration, where you have a user or agent sender. We send it to a like messaging platform. Yes, it's the same thing which powers LinkedIn like messages, literally the same platform. And we have a messaging service which essentially parses it into a database. It tries to deliver through a delivery service online through an agent orchestrator service. And in case the delivery fails, it keeps attempting a nearline retry. And in case of traffic shifts, we use a nearline retargeting service, again through a similar mechanism of using a local queue and an aggregate queue, retargeting and like delivering. So we are able to piggyback on a lot of the resilience mechanisms we have for delivering the like messages on LinkedIn, which is subject to exactly the same problems with an agentic workload. And ultimately, it reaches the user or agent receiver. Now, the reason we put the orchestrator in between is because we did not want people implementing all these like messaging abstractions. We just wanted them to implement RPCs. So you just implement an RPC endpoint, we'll call you under the hood, it's all a like message. So execution concurrency is very important. You don't want it to all be very linear, but sometimes you want it to be linear because context matters and reference matters. So we have this concept of like threads, which is again really similar to messaging threads, where we will do sequential first in, first out delivery within a thread. If you want parallelism, you just create multiple threads. So this is how you do sequential versus parallel like balancing. And we use like distributed storage to synchronize state. How does the agent remember things? LLMs are stateless, so we have to build some form of like memory. So our like memory is actually scoped and layered. We have like working memory, which is task context within the context of a particular task, right? This is your conversation history as well as, hey, that particular task. We also have like long-term memory, which may be episodic or procedural. Like episodic is what happened in a given episode or a session of interaction. Procedural is recording information about actions taken by the user. We also have this interesting concept called as collective memory. And it's scoped and layered because you may want to learn things at various levels of granularity. For example, in the context of the hiring agent, what does a particular recruiter do? What do all recruiters in this company do? What do all tech recruiters do, for example? As you can see, various levels of learning. Now, you have this, you also have to retrieve from it, right? So context lengths are limited. Inside the LLM, you can't throw everything inside the memory into it. Though with Llama 4, the promise is like, huge context length, so you don't need precise retrieval, but let's see. So even if you have huge context, the problem still remains that it's really slow and it's more expensive to process, right? Because ultimately you're bound by the number of tokens And in general, you will see more hallucinations with a longer context. So we have 3 common techniques for handling this. You do like most recent end for conversations, because most likely you're referring to something which was said in the recent history. You also do like summarization. This is useful if you're dealing with something really old and you want to summarize it, quite like human brains, right? You don't remember every detail of, say, like what happened a year back. You remember what happened yesterday probably really well. Same thing, it's an organic form of compaction. And one really useful technique which we use heavily is semantic search via vector embeddings, so that you can retrieve the most contextually appropriate information. So how does the agent do things, which is skills? You may have heard of this called as like tools, but skills are way more than tools, because skills encapsulate both what and how. So it takes various shapes and forms. You can do RPC calls, database queries, it can be prompts, it can even be other agents. And we are adding support for MCP right now, which is Model Context Protocol, which is all the rage right now for calling tools. Right? So like originally we had implemented these pretty manually, and later we realized that, you know what, it's not going to scale to implement it like manually, so we inverted it. So we said, hey, rather than us implementing tool calls into every LLM application, let's build a central registry, which we called as the Skill Registry, and let's have the source of truth expose these, right? And we will register it in a Skill Registry, and we will retrieve it at runtime. So right now, rather than every client build tools to call endpoints or other skills, every tool owner or every service owner or every agent owner exposes an abstraction, quite like MCP actually, although we predated MCP, which is why we built this. We have a lot of like services at LinkedIn exposed over gRPC, so we built some really cool automation for gRPC services, so that developers only have to write some options and stuff automatically gets registered and works. And we also built a UI to go and search for skills. We have a text-based search and an embedding-based retrieval-based search. And we also built like LangChain adapters for you to go and load these skills like dynamically. So how does this all come together at runtime? So you get a task, right? You say search for a like mid-level engineer. Rather than hard code the tool, you dynamically like figure out from the skill registry what tool is most appropriate, fill in the arguments to it using the power of the LLM, and after that execute it. So your agents have an incredible amount of agency with this approach, since you're exposing all the tools to them effectively, as opposed to you hard coding and controlling the flow. Now, if you still want to control the flow, you can. No one's stopping you. It's just that if you like want to give them agency, you can. Observability is another thing which is really important. So this describes our overall flow. Classic distributed systems, you have various forms of observability, right? You have traces, you have events, logs, etc. The problem with these agentic systems is that they are inherently non-deterministic. So you can have various different flows going on all the time. So your classic observability doesn't work that well. It's really hard to get insights. We've had to build various forms of sophisticated aggregation, which is then fed into industry standard systems like OTel in order to generate a trace. And we again do further processing on it in order to generate analytics dashboards, which like developers can consume and can look at it. And we also have 2 use cases for it. One is, hey, when you're debugging locally to see something, when you can visualize what happened to a single invocation. And the second is in production at scale to look at an aggregate set of use cases. So like what are some of the important lessons we learned? The first is standardize a bunch of these common things, automate boilerplate, and like democratize access to your developers. You do not want them to be doing the redundant parts of the job again and again. When like building agents, you want them to focus on the actual job of building the agent, just like any other framework. Another very important thing, most of the time in an agent, if you're doing simple workflow automation, you may not even like need an LLM. You don't even like need AI. Surprise, surprise. Procedural code works a lot better, lot more stable, faster, etc. So please, please be careful. Only if you need reasoning, go to the left. Otherwise, stay on the right, which is just use procedural code. And again, if you have a quality scale or a like latency constraint, try to pick a custom model. Otherwise, simply use a commercial cloud-hosted model because the overheads simply aren't worth it. Here is the model customization, like pyramid. And again, use the techniques at the bottom of the pyramid as much as you can, and try to use the techniques at the top as less as you can. Because it becomes really expensive, hard to maintain, the models are evolving quickly, so you need to be very thoughtful about what you're doing. So what this essentially means is, as long as you can, use retrieval augmented generation, prompt engineering, cache augmented generation if you want, and start doing various forms of fine-tuning or like pre-training or ground-up training only if you really, really, really need to. It is still software deployed to production. It's not a prototype, so please build for availability, like resilience and scale. You need robust evaluations, like Daniel called out. Trust, privacy, security, responsible AI, all these things are important. And you also need observability. Without observability, it's really easy to fly blind when things go wrong, because everything at the end of the day is very non-deterministic. This is very important. So this shows an elephant like dancing. The space is changing really fast. So it's important to ensure that whatever you like build can also adapt really fast. So 2 examples I'd like to take, right? We picked LangChain and LangGraph. However, the way our software is like built is essentially it's layered. We have these lower level like platform components, and we have like LangChain and like LangGraph adapters. So today we like it. Tomorrow some other framework comes out, or we want to try something. We have the ability to switch relatively cheaply without changing the entire ecosystem, right? Another example is MCP was not a thing last year when we built this, but right now it is a thing. So our skill registry can be integrated into MCP. And in general, always try to buy, don't try to build. Only try to build if it's simply not available, because again, the space is moving really fast. New things keep coming out every day. If you invest a lot in your own stack, it may be really hard to adopt new things. UX lessons. So this is also interesting. I mean, a lot of apps just say, stick a text box, have the users enter things into it. Sounds very ideal, actually doesn't work. Because it's a lot of overhead for users to remember, oh, I have a text box, what do I type into it? I don't know if it'll work or not, right? So you sometimes have to provide finer grained controls. Here you can see an example of our AI-enabled message automation. So here we have a text box for the humans to edit the AI-generated message. But if you see the personalization filters, rather than have the human type it out, it's easy to provide some clickable boxes so that they can click on it. Right? Progress indicators. A lot of these AI agents do heavy work. It's asynchronous. If you're going to show spinners, or if you're just going to show a static UI and the user keeps waiting, they will get irritated. So one of the lessons we learned is that only if you're going to respond reasonably fast, show these spinners, show these progress bars. Otherwise, it's better to use an explicit async flow with some ETA and use a async notification mechanism to inform users when the task is done. And with it, I am done. So Q&A.
Hello. Thank you for the talk. My question is on security specifically. So in a skill registry, if agents by default have access to all these skills, and it would be easy for a developer to register a skill for a service which indirectly has the ability to, say, destroy data, now every AI agent implicitly has this power that no one planned for. So talk a little bit about the security of the skill registry.
So that's a great point. Every agent does not have access to every skill. The way it works is we have this concept of service principles at LinkedIn, which is used for, determining which client has authorization to call which endpoint. Those are transitively applied even for agents. So if you essentially build an agent, you have to have the service principals registered to be able to call the skill service principal, so which is how we enforce this.